Every single morning, millions of people bite into the same sandwich. Same taste, same shape, same soft English muffin, same perfectly round egg. Imagine trying to cook millions of identical breakfast sandwiches and not messing up even one. Now imagine doing it across thousands of locations every single day without slowing down. The Egg McMuffin looks simple, but behind that simple bite is a system so precise, so synchronized, it feels almost mechanical. The real question is, how does one of the world's most famous breakfast sandwiches stay exactly the same, whether you buy it in New York, Tokyo, or London? Let's step inside the process most people never think about. This is Infusions and Elements, where we uncover the hidden engineering behind everyday products. If you're fascinated by factory secrets like this, make sure you subscribe and turn on notifications so you never miss what's really happening behind the scenes. The big question: how do you standardize breakfast? Breakfast is unpredictable. Eggs break, bread burns, cheese melts unevenly, timing goes wrong. At home, it's normal. At global scale, that's chaos. The Egg McMuffin solved that chaos decades ago, and the secret starts long before you reach the restaurant counter. Inside the English muffin factory, before the egg, before the cheese, before the meat. It starts with the English muffin. Massive industrial bakeries mix flour, water, yeast, salt, and a small amount of sugar in mixers large enough to hold hundreds of pounds of dough at once. These mixers rotate with controlled force, developing gluten evenly so every muffin has the same structure. The dough is portioned automatically, cut, rounded, rested. Machines divide dough into identical pieces within fractions of a gram. Consistency isn't optional, it's everything. After proofing, where yeast ferments and creates air pockets, the muffins travel through long tunnel ovens. Some ovens stretch longer than a basketball court. Thousands of muffins move through heat at once, each one baked at the exact temperature for the exact number of seconds. Too dry? It fails. Too soft? It collapses during toasting. After baking, they're cooled on conveyor belts that snake across the facility. Cooling is critical. If packaged too warm, condensation ruins texture. Metal detectors scan them. Optical sensors check size and color. Anything outside tolerance is removed automatically. The approved muffins are sliced precisely at the center, not too deep, not too shallow. Then they're packaged and shipped to distribution centers that supply individual restaurants. By the time you see one toasted, it has already traveled through a system designed for zero variation. The Canadian bacon process. The next layer is the round slice of Canadian bacon. Unlike crispy breakfast bacon, this is lean pork from the loin. It's trimmed, cured, and cooked in specialized facilities that focus entirely on uniformity. Large pork loins arrive chilled. They're inspected, trimmed of excess fat, and injected with a curing solution. This solution enhances flavor and helps preserve texture. After curing, the loins are cooked in massive ovens or steam chambers. Temperature sensors monitor internal heat to ensure food safety and consistent doneness. Then comes slicing. Industrial slicers cut each loin into perfectly even rounds. The thickness is calibrated precisely. Too thick and it overpowers the sandwich. Too thin and it dries out during reheating. The slices are flash-cooled, stacked, packaged, and frozen for transport. Every slice must fit the muffin exactly. No overhang, no shortage. That circular symmetry isn't accidental. The cheese you never think about. The square of cheese may look ordinary, but even that is engineered. American cheese slices are produced in massive batches, blended to achieve smooth melting at specific temperatures. The goal isn't sharp flavor, it's melt performance. The cheese must soften quickly when placed on hot meat, not separate, not oil out, not remain stiff. It's cut into uniform squares and individually wrapped or stacked in sheets, ready for fast assembly. Even the melt timing is calculated. The egg, the heart of the sandwich. Now comes the most interesting part: the egg. Unlike many fast food eggs that arrive pre-cooked, the Egg McMuffin uses real cracked eggs in restaurants. That changes everything. Eggs are supplied by large-scale farms where they're washed, graded, and inspected. Automated candling systems shine light through each egg to check for defects. They're sorted by size and packaged carefully to minimize cracking, then shipped chilled to restaurants. But the real magic happens in-store. Inside the restaurant precision breakfast engineering, breakfast hours begin early. Staff prepare a specialized grill designed with circular metal rings. These rings control the shape of each egg. A worker cracks a fresh egg into each ring. The ring keeps the egg perfectly round, uniform, sized to match the muffin. The yolk is broken intentionally for consistent texture. Then a small amount of water is added to the grill surface, and a metal lid covers the eggs. Steam builds instantly. This combination of direct heat and steam cooks the egg evenly from top and bottom. No flipping required. Within minutes, the egg firms up into that signature shape. It looks simple, but the timing is strict. Too long and it turns rubbery. Too short and it's undercooked. Each batch moves in rhythm with incoming orders. By the way, if you're enjoying seeing how something so ordinary is built with such extreme precision, you're going to love what we're uncovering next on this channel. We break down the hidden systems behind the world's biggest food and factory operations. So if you haven't subscribed yet, now's the perfect time. The toasting system. Meanwhile, the English muffins are split and placed into vertical toasters. These aren't standard home toasters. They're calibrated to toast hundreds of halves per hour. The heat is consistent. The browning is predictable. Each muffin emerges lightly crisp on the inside, soft on the outside. Exactly the texture needed to absorb melted cheese without collapsing. The assembly line moment. Now everything converges. Bottom muffin half, hot Canadian bacon, cheese slice, freshly steamed egg, top muffin half. The heat from the meat begins melting the cheese immediately. No extra step needed. The entire sandwich is wrapped quickly to retain warmth. From cracked egg to finished sandwich can take only a few minutes. During peak breakfast hours, a single restaurant can produce hundreds of Egg McMuffins per hour. Across thousands of restaurants worldwide, that becomes millions per day. It's not just cooking, it's choreography. Surprising facts you didn't notice. The circular egg wasn't an accident. It was designed to make the sandwich easier to eat and visually symmetrical. The muffin texture is engineered to balance softness and structure so it doesn't fall apart even when wrapped. The steam cooking method ensures consistent doneness without requiring complex flipping. And every component is designed around speed. Because breakfast customers don't wait long, they move fast. The system must move faster. If you enjoy seeing how everyday food is engineered behind the scenes, there's a lot more hidden in plain sight. And the deeper you look, the more fascinating it becomes. Why this process works. Most people think fast food means shortcuts. But the Egg McMuffin proves something different. Standardization isn't about cutting corners. It's about controlling variables, from flour protein percentages in the muffin, to cure time in the pork, to grill the temperature in the restaurant. Every detail is measured. Even delivery logistics are timed, so ingredients arrive fresh and rotate before expiration. Restaurants follow strict food safety guidelines, temperature checks, and cleaning schedules. It's a system built on repetition and precision. What happens during rush hour? Picture 7:30 a.m. Orders stack up, cars line up, mobile notifications beep. Inside, eggs are cracking continuously, muffins are toasting non-stop, bacon is heating in batches. Yet the sandwich you receive looks exactly like the one made at 6:05 a.m. That's because the workflow is modular. Each station handles one task, no confusion, no improvisation. The grill operator focuses only on eggs. Another team member manages muffins. Another assembles. This division of labor keeps quality stable even under pressure. It's industrial thinking applied inside a small kitchen, building toward the final bite. By the time the wrapped sandwich reaches your hand, it has passed through farms, factories, distribution centers, cold storage trucks, restaurant prep stations, calibrated grills, and timed assembly routines. Also, that first bite feels effortless. Soft bread, warm egg, savory meat, melted cheese, simple on the surface, extremely engineered underneath. And here's what makes it fascinating. The system only works because every part trusts the other part to perform perfectly. If the muffin size changes, the egg ring must change. If the bacon thickness changes, melt timing shifts. If grill heat fluctuates, texture changes. So nothing is left to chance. The satisfying truth. The Egg McMuffin isn't just a breakfast sandwich. It's a case study in industrial food precision. A small handheld example of global supply chain coordination. Millions made daily. Each one is nearly identical, from the factory floor to the restaurant grill. And most people never think about it. They just take a bite. Next time you unwrap one, you'll know you're holding the result of synchronized farming, baking, curing, shipping, heating, and assembling, all compressed into one simple sandwich. If you want to see more factory secrets hidden inside everyday products, subscribe and stay curious, because the next process we uncover might be something sitting in your kitchen right now, and you'll never look at it the same way again.